In this tutorial, we'll create a fairly realistic apple. First thing we want to do is to delete everything in our scene. We'll need a reference image, so feel free to use any apple picture you can find. Just make sure the apple is viewed straight on, with a front-facing perspective rather than an angled camera view. So we need to press numpad 1 to switch to front view, as we want the reference image to be aligned with this view. Press Shift A to open the menu and choose Image, Reference. Now we simply browse through the folders to find our reference image and import it into Blender. Now, for the modeling phase, we'll start with a mesh that most closely matches the shape of an apple. This is fairly straightforward. In any 3D software, when modeling an object, especially a simple one, it's worth asking what the best starting mesh is. The answer is usually the mesh that most closely resembles the final shape. So if you want to model a glass, start with a cylinder. Want to model a cardboard box? Start with a cube. Want to model a soccer ball? You guessed it, start with a sphere. Want to model an apple? The closest starting point we have is actually a sphere. So press Shift A, select Mesh, UV Sphere. Now we will scale it up a little bit, by pressing S and dragging the mouse. We want to scale the sphere until it is the size of the apple in the reference image. We can then move the reference image in the Y-axis so it won't stand in the way while we're modeling. Back in front view, we want to start editing our mesh, so let's select it and press Tab to enter edit mode. We should also enter wireframe mode as it will allow us to see through the mesh. Press C and select wireframe. We can switch to edge select mode, since working with edges makes the most sense right now. We need to select a loop. To do that, hold Alt and select an edge of the loop you want to select. An edge loop is basically a chain of edges, where each edge is connected end to end in a smooth path. Now to switch to front view, we can hold Alt, as well as the middle mouse button, and then drag the mouse to rotate the viewport until it snaps to the front view. We will use proportional editing mode. This allows us to edit the selected edges, while smoothly affecting nearby ones. Press G to grab the selected loop and move it downwards so the mesh matches the shape of the reference image. Continue selecting edge loops and scaling or moving them as needed. We can use the scroll wheel to increase or decrease the area influenced by proportional editing. If needed, we can add more loops. However, since the bottom of the sphere consists only of tris, Ctrl-R cannot be used to insert additional loops there. Instead, we will subdivide it. Switch back to solid mode. Press B to draw a selection rectangle. Select all the bottom edges. Then right-click and choose Subdivide. A menu will appear in the bottom left corner. Expand it and set the number of subdivisions to add. 2 works well in this case. The apple has a blossom end at the bottom, which curves slightly inward. We can drag the outer edges down while keeping the inner edges in place to simulate that little hole. To go even further, we can select and drag the vertex in the middle. So switch to vertex select mode. Select the vertex and drag it up slightly. Feel free to increase or decrease the proportional editing area as needed. Now we will do the same with the upper vertex. Since we want to move the vertex only along the Z-axis, we can press C while grabbing it. We want to create another loop, so press Ctrl-R, while the mouse is over the edges where you want it to be added. Keep adjusting the loop positions. It looks good, but it's too symmetrical, so it feels artificial. With proportional editing active, we'll move some vertices to intentionally add irregularities to the mesh. In this case, I used the reference image as a guide and tried to recreate what I could see. We can also simulate those irregularities on the bottom of the apple. Let's add some more irregularities to the top part as well. The mesh still shows the polygons, but we can easily fix this by setting it to shade smooth. We can also add a subdivision surface modifier. Let the levels for the viewport stay at 1 and for the render at 2. This ensures we don't have to deal with too many polygons while working, which would slow down viewport performance and increase memory usage. For the render, we want the mesh to look smooth and detailed, so keeping a higher subdivision level there is a good idea. Now we need to model the stem. A cylinder is the best base geometry to start with. We want the ends of the cylinder to be filled with triangles, so open the menu in the bottom left corner and set the cap fill type to triangle fan. Let's position and scale the cylinder. Quick tip: if you want to scale an object along all axes except one, press S, then hold Shift and the axis you don't want to affect. This also applies to other transformations, such as moving or rotating. When placing the cylinder, make sure its bottom end is inside the apple. Enter edit mode and keep editing the stem. Use Ctrl-R to create loop cuts. Select the loops and scale them according to your needs. We can use the bevel tool in the top of the stem, but before that, we should apply the scale, otherwise the bevel tool won't work as expected. So now press Ctrl-B to create a bevel. Use the scroll wheel to add loops if you feel like it. For now, one will suffice. Again, the stem looks too symmetrical, so we'll intentionally add some irregularities. To bend the stem, we'll use a simple deform modifier. For it to work, we first need to change the mesh's origin point. That's fairly easy in edit mode, and with wireframe enabled, select the bottom of the stem. Press Shift-S and choose Cursor to Selected. This will place the cursor in the selected area. Switch back to object mode, right-click the stem, then choose Set Origin to 3D Cursor. We will add a subdivision surface modifier to give the mesh a smoother look. Now we can add the simple deform modifier, because the mesh will deform starting from its origin. We want to bend it, so feel free to do so as you will, playing with the axis and the angle. I ended up adding some more simple deform modifiers to bend the stem further, and even add a slight twist. The modeling is done, now it's time to texture the mesh. Select the apple and add a new material. Feel free to name it apple or something else. Now we want to open the shader editor, so let's split the viewport. In the top left corner of the new panel, switch the editor type to shader editor. Now we can see the materials nodes. Before continuing, there's a link in the description to download the textures used in this tutorial, so go ahead and download them. The textures are from texturekin.com, so you can download them there as well. However, I did modify the apple texture slightly, so you may want to download mine instead. Texturekin is an awesome website, with a bunch of cool high-quality textures you can use, so when you have the time, feel free to give it a try. So now let's add an image texture node to our material, press Shift-A, type image, and select the image texture node. We want to connect the color output with the base color input. Then open the diffuse apple texture you saved earlier. We can't see the texture in the 3D viewport because we're in solid mode, but if we switch to material preview, we'll be able to see it on the mesh. The material looks good, but it still needs some adjustments. Let's start with roughness. Roughness controls how shiny or matte a surface appears. It's part of the principal BSDF shader and affects how light scatters across the material. Higher values create matte surfaces, while lower values make the material appear shinier. For an apple, I would say about 0.35 will look good enough. Apples have natural bumps, and we'll simulate them using a noise texture node and a bump node. Add a noise texture and a bump node. Connect the factor output of the noise texture to the height input of the bump node, then connect the bump node to the principal BSDF node. By adjusting the bump node values, we can make the noise texture more or less visible on the apple. We want the bumps to be barely visible, though you can exaggerate them more or less, depending on your needs. The same process for the stem. Select the stem, create a new material, rename it. In the shader editor, create an image texture. Again, the diffuse texture can be downloaded from the texturekin.com website, though I've also provided a download link in the description. Adjust the roughness and any other settings as you see fit. Keep in mind that the stem is rougher and less shiny than the apple skin, which means its roughness value should be higher. This time, instead of using a bump node, we'll use a normal map. We need to create a normal node and an image texture node. Connect the normal output and input. The normal map we'll use can also be downloaded from TextureCAN, as it corresponds to the diffuse texture we used earlier. Again, I've provided a link in the description. We need to make sure the color space is set to non-color, otherwise the normal map won't work as expected. We can adjust the normal map strength. The higher the value, the more pronounced the bumps will appear. For this stem, a value of 0.6 works well. We'll slightly adjust the texture sizes, starting with the apple skin. Select the apple, then switch the left panel to the UV editor. Enter edit mode and select all the UVs by pressing A, then scale them horizontally by pressing S, followed by X. We're aiming for the texture not to be too stretched. By scaling the UVs horizontally, we can make the texture appear more proportionate in the 3D viewport. Now we do the same for the stem. Although it's not necessary in this case, you can view the texture in the UV editor by selecting it from the top menu. While scaling the UVs, make sure to zoom in on the stem in the 3D viewport, so you can see the changes in the texture. For further realism, we will paint the texture of the stem. With that in mind, switch to texture paint mode. Apple stems are usually yellowish, so we'll start by using the eyedropper to pick the yellow color from the apple skin. We can paint in solid mode to reduce performance issues and speed up the process. While in solid mode, if you see the normal map instead of the diffuse map, it just means the normal map node is selected. Simply go to the shader editor and select the diffuse map node. Choose the soft paint brush and begin painting the stem. Don't overdo the brush strength, as we want to preserve the natural details of the wood. Feel free to switch to material preview mode at any time. Stems usually have some green tones, so feel free to adjust the color as you go. We'll make the end of the stem a bit darker. Now that we've painted the stem, we need to save the texture, otherwise we'll lose our work as soon as we close Blender. So go to the UV editor. Now we can see the painted texture. Save the texture by going to the top menu, Image, Save As. With modeling and texturing done, it's time to move on to rendering. First things first, we want to hide some objects in the scene that we won't need anymore. We start with the reference image. Select the image and hide it in the scene collection at the top right. Make sure to hide it both in the viewport and in the render, otherwise it will show up in the final render. Now, if we switch to rendered view, we'll see that the scene is too dark. That's because we haven't set up any lighting yet. The render engine is set to Eevee by default, but we want to switch it to cycles. There are several differences between Eevee and cycles, which we'll cover in another tutorial. Now let's start setting up the lighting. Add a sun light by pressing Shift A, then go to Light. Sun. Move the light upwards. To generate more interesting shadows, instead of having a boring midday sun, move it slightly to the left and down. We want to simulate an afternoon light, so rotate the light to create a softer, angled direction, typically from the side rather than directly overhead. You can point it toward the apple if it helps with positioning, but with the sunlight, the location doesn't affect the lighting, only its rotation does. In other words, moving the sunlight won't change the scene, but rotating it will affect the direction of the light and shadows. We can also adjust the angle value of the sunlight. This setting controls how soft or sharp the shadows appear. It simulates the size of the sun in the sky. A smaller angle represents a smaller sun, producing sharper shadows, while a larger angle represents a bigger sun, creating softer shadows. We will add a plane so the apple can cast shadows on it, creating a more appealing render. Scale the plane so it's much larger than the apple. Move the plane down so it sits directly below the apple. Now we will create a simple material for the plane. In this scene, we want the plane to match the background, so use the eyedropper tool to pick the background color. We also want the plane to have some reflections. so lower the roughness value. We need to set the resolution for the render. In this case, we can use 1920 by 1080 pixels. Now let's set up the camera. Add a new camera by pressing Shift-A. Camera. We need to move and rotate the camera so it captures the entire apple. A good way to do this is to switch to the 3D viewport in the left panel. Then, with the camera selected, press numpad 0 to see what the camera sees. You can now move or rotate the camera in the right panel while watching the changes in real time in the left panel. We will change the focal length to 30 mm. Adjust the camera's position and rotation. Feel free to press N to open the right panel, which makes it easier to move and rotate the camera precisely. Let's check how it looks in rendered view. Looking good. It's time to render our scene. First, let's join the areas again. Move your mouse to the middle of the panels, then click and drag to the left and slightly upward. Now select the render panel in the right menu. If your GPU is available, change the device to GPU compute to speed up rendering. In most cases, GPU rendering is faster than CPU rendering, but the actual speed depends on your hardware. For the render samples, we will use 300 as the maximum. This is good enough for this render. Keep the denoise option checked. Denoising removes noise or graininess from your renders. For GPU rendering, the tile size should be large. For example, 256, 512, or even 1024. In this case, we will use 512. We can also set the output file and choose the file format based on our needs. Everything's set. Hit render. That's it. If you liked the video and learned something from it, don't forget to hit the like button and subscribe for more tutorials. Leave a comment, tell me what you think. Thank you for watching.